Dear students, today we shall solve some problems on lumped heat transfer analysis. Problem number 1. A 40 centimeter into 40 centimeter copper slab 5 mm thick is at a uniform temperature of 250 degree centigrade is suddenly exposed to air at 30 degree centigrade. Find the time taken at which the slab temperature becomes 90 degree centigrade. Take the following properties of copper. H is equal to 90 watt per meter square Kelvin, rho is given, Cp is given, K is equal to given. So then, first, what is the initial temperature of the slab is given as 250 degree centigrade, and fluid temperature is equal to T infinity equal to 30 degree centigrade, and final temperature attained by the slab equal to 90 degree centigrade. Then length, we know that length of the slab is given as, the thickness of the slab is given as 5 mm. Then the characteristic length of the slab will be equal to 2.5 mm. It will be 2.5 into 10 raised to minus 3 meters. Then find first thing you have to find out Biot number. What is Biot number? Biot number is defined as H into LC by K. So H is, we know the value of H. LC is 2.5 into 10 raised to minus 3. Substitute the values and we will get Biot number equal to 6.08 into 10 raised to minus 4. It is less than 0.1. Less than 0.1. Hence lumped system analysis is applicable. So applying the lumped system equations, what is that equations? Here, so it is T minus T infinity, T infinity equal to T minus T infinity equal to Ti minus T infinity equal to exponential H by rho Cp Lc into T. So we know substitute the value of T, Ti and T infinity. Ti is 250 degree centigrade. Temperature attained by the slab is at any time is 90 degree centigrade. Fluid temperature is 30 degree centigrade. So substituting the values of H, rho, Cp, Lc and we can find out the time required for the slab to attain a temperature of 123 temperature attained by the slab to time taken by the slab to reach a temperature of 90 degree centigrade is 123.43 seconds. Now I will go to the second problem. A solid steel ball 5 cm in diameter and initially at 450 degree centigrade is quenched in a controlled environment at 90 degree centigrade. So with a convection coefficient of 115 watt per meter square Kelvin. Determine the time taken by center to reach a temperature of 150 degree centigrade. Properties of a steel ball are given. So here the same thing, temperature attained by the sphere is at any time is 150 degree centigrade. Initial temperature of the sphere is 450 degree centigrade and T infinity is 90 degree centigrade. So H is given, rho is given, K is given. So diameter of the ball is 5 centimeters. So radius of the ball is equal to 2.5 centimeters. So then characteristic length of a spherical ball is, we know that V by A equal to R0 by 3 is equal to D0 by 6. You can find 0.05 by 6. So we'll find out the Biot number. Biot number is equal to HLC by K. We'll get 0.0208. It is less than 0.1. So hence lumped system analysis using the same expression here, T minus T infinity divided by Ti minus T infinity exponential minus H by rho Cp Lc T. Substituting the value of T, Ti, T infinity, H, rho Cp, Lc, and we can find out the time taken by the the steel ball to reach a temperature of 150 degree centigrade equal to 440.35 seconds equal to 7.34 minutes. Another problem. It is a cylindrical wire, aluminum wire, 1 mm diameter and 200 degree centigrade is suddenly exposed to an environment at 30 degree centigrade with H equal to 85.5 watt per meter square Kelvin. Estimate the time required to cool the wire to 90 degree centigrade. It is the first part. Wire. It is a small diameter wire. Small diameter and long wire. Diameter is small and the length is long. For that again we can use the formula this Bi equal to again Lc for cylindrical wire it is V by AC. Characteristic length equal to R0 by T for a cylindrical wire is equal to D by 4 equal to 2.5 into 10 raised to minus 4. Find the Biot number. It comes to be Biot number is equal to HLC by K is equal to 85.5. This is 1.047 into 10 raised to minus 4. It is less than 0.1. Hence lumped system analysis is applicable. So using this same expression here, So substituting the value of T, Ti and T infinity and substitute the value of H, rho Cp, Lc, we can get the time required by the for the ball to reach a temperature of 90 degree centigrade is 7.4 seconds. Now second bit, he is asking the second bit also here. What is second bit? If the same wire is were to cool in air, placed in air stream with H equal to 11.65 watt per meter square Kelvin, what would be the time required to reach it to 90 degree centigrade? So time required for the wire to reach a temperature of 90 degree centigrade only, but the H is same. Wire is cooled in air stream instead of H equal to in water or something, it is placed in air. H is same. So you say again, you find Biot number. Biot number is equal to HLC by K equal to this is good. A Biot number equal to 1.427 into 10 raised to minus 5. It is less than 0.1. So hence lumped system, applying the lumped system analysis, you express using these expressions, then you are substituting the value of T, Ti and T infinity, you will get the time required for the wire to reach a temperature of 90 degree centigrade is 54.3 seconds. Now this is the fourth problem. Steel ball bearings, K equal to 50 watt per meter Kelvin, alpha equal to 1.3 into 10 raised to minus 5 meter square per second, 40 mm diameter, is heated to a temperature of 650 degree centigrade. It is then quenched in a oil bath at 50 degree centigrade. That means Ti equal to 650 degree centigrade, T infinity is equal to 50 degree centigrade, where the heat transfer coefficient is estimated to be 300 watt per meter square Kelvin. Calculate the time required for the bearings to reach a temperature of 200 degree centigrade. So first bit we will solve. So this is again a spherical ball. So for a spherical ball, characteristic length equal to R0 by 3. So Biot number is equal to HLC by K equal to this, you will get 300 into 0.02 by 50 into 3, 0.04. It is less than 0.1. Hence lumped system is applicable. So using this expression, same expression here. So here what is that? Here is he has not given the value of density and specific value. He has given instead of it, he has given K and alpha. So we know that the thermal deficit equal to K by rho Cp. Thermal deficit alpha equal to K by rho Cp. Rho Cp equal to K by alpha. Rho Cp equal to K by alpha. Substituting the value of rho Cp as K by alpha. So then rho Cp as K by alpha. Rho Cp as K by alpha. In these expressions, we will get the value of time taken by the ball to reach a temperature of 200 centigrade, 118.5 seconds. Okay. Then he is asking the second bit. So what is the total heat removed from bearings during a period of 118.5 seconds? So we know that total heat obtained is obtained total heat transfer obtained is given by this expression. Okay, delta U equal to minus rho Vc Ti minus T infinity exponential minus HAST by rho Cpv minus T. Substituting the value of rho V as K by alpha, volume of the sphere equal to 4 by 3 pi R0 cube and Ti minus T infinity exponential. So again rho Cp as K by alpha. Then substitute the value of temperature. We want a total heat removed during a period of 118.5 seconds. So 118.5 seconds during this period. So substitute the value of T as 118.5 seconds. So you will get 58 kilojoules. Total heat removed is 58 kilojoules. Then he is asking the third bit, instantaneous heat transfer rate when they reach immersed in an oil bath and when they reach 200 degree centigrade. So when they are immersed in an oil bath, in instantaneous heat, when they are immediately immersed in a oil bath, that is instant. We want heat transfer at time t equal to 0. So Q at t equal to 0 equal to HAS Ti minus T infinity. See, Ti minus T infinity. Ti is the initial temperature of the solid ball. So you will get the area is the surface area of this ball is 4 pi r square. So you will get 650 minus 30. Instantaneous temperature you will get as 904.7 watts. Then again the same formula, instantaneous heat transfer rate when the temperature of the bearings reach to 200 degree centigrade, that is at 118.5 5 seconds. So here HIS Ti minus Q instantaneous heat transfer is given by HIS Ti minus T infinity exponential minus HAS T by rho Vc. Again rho Vc as K by alpha we have substituted, and temperature time taken is 118.5 seconds. Time for the 108 substitute time as 118.5 seconds, and substituting the values here we'll get the instantaneous heat transfer rate when the bearings reach a temperature of 200 degree centigrade. You will get Qt equal to 226.16 watt. So see, these are the some of the problems we have solved. So we will continue the next problems, some more problems we shall do it in the next class. Thank you.